Hello, this is a lesson 12. The goal is identify and solve future value of annuity problems. So what is the annuity? So it's a financial plan character, character, characterized, characterized by regular payments. For example, we have a 401k plans. So we often hear that, right? All right. So last time, what we did a simple interest and then compound interest formula, right? So here is the story. So single deposit now, the present, right? So we have a $21,110, but made no future investment. So this account grew $50,000 in 18 years. So picture is like this. The principal present right now. So $21,000, $110, $21,110, and then future in 18 years by using compound interest formula, they have 50, missing 10, right? Yeah, $50,000 in the future, right? Okay, here is another investment, annuity. So we have regular deposit or payments made over time. Each earning interest is called annuity. Here is a picture of a future value annuity. So let's take a look. So we have a payment $50, payment $50, payment $50. Keep doing that. Payment $50, and then future value, being money in the future. So we called this is a future value annuity. Okay, here is the formula. This picture I just explained to you, right? Okay, the formula looks very hard. I'm gonna show you just only one, and then we can use the calculator. So let's take a look. A typical pack a day smoker in Illinois spends about $307.50 per month on cigarettes. Suppose the smoker invests that amount at the end of each month in an investment fund that pays a return of 4.9% compounded monthly. What would the account be worth after 40 years? Okay, all right. So let's do that. 307.50 is payment, right? So that's the R, which is payment. And we have 4.9%, but then in that case, it's in decimal for R, right? So we move to the decimal point twice to the left. Beyonce method, right? To the left, la 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 la, to the left. So it's a 0.049. Okay, let's using the R equal to 307.50. And 1 plus R equal to 0.049 over M. M indicates number of compounding periods per year, right? Okay, so we have 12 months because they say that compound monthly, right? 12 months. So we have 12. Okay, this is the one, yeah? All right, let's take a look. The power exponent. Exponent has m times t. M in the case is 12. T in the case, let's see. The question said that what would the account be worth after 40 years, right? So it's only the years, right? So this will be T in years, right? So that will be 40 here. Okay, now minus 1. Ooh. Okay, all over we have R over M, right? So R in the case 0.049 over M, which is the number of compounding periods per year. So we had 12 because compound monthly, right? So 12 a month in year. So let's calculate this one. I will show you how to use decimals. This one, okay? With the power, right? Okay. All right, so the payment, which is $307.50, 307.50, and parentheses, and then I'm gonna make another parentheses. Ooh, what's going on? Okay, 1 plus, let's do 1 plus first, and then R over M, which is 0.049, 0.049 over, on over here, over 12, and we make the exponent, and then we have two numbers, so I want to make a parenthesis, 12 times 40, okay, and then minus 1, the whole thing parenthesis minus 1, so that would be, can I move here? Yeah, okay, I can move here. Minus 1. And then everything over 0.049 over 12 again, one more time. Yeah, so let me see. This whole thing. So I want to make a parenthesis everything here and there. And whole thing divided by R over M, which is 0.049, missing 4 again, over M, which is 12, right? Oh, I made a mistake somehow. I don't get the number. Let me check this one. I think there is too much parentheses, so the power does not read. Let me take out. Is this power? Oh my gosh. Okay, let me delete this power. I want to put this one here. Okay, power. And then this is 12 times 40. Okay, this is the answer. 457,000 $187 35 cents. Yeah. So let me make a screenshot this one. Okay. So let me put this one here. This is by using calculator. So we got the same answer here, right? So you can see that this number same as this one. Yeah, this is the answer. Okay, so we have a TMV calculator for financial calculator. So let me show you how to use this one. So you are free to use this calculator rather than by using hand because this one takes a lot of time, right? Okay, so let's just Google it. TVM calculator. So just Google it, right? So I type TVM calculator, the first one here. All right. The question said that each month, at the end of each month, right? So we are using and. Let me explain to you what is and beginning later on. So for now, just click the and as it is. Yeah, it's already there, right? And present value, they don't say anything about the present value, so we make it 0. And the payment, the smoker pay his cigarette expenses, right? So here, 307, 307.50. And then feature value, that is what we are looking for, right? So I can annotate it, I'll do later. So that is what we are looking for. So we will click that on later on. The rate, looking at this one is percent, so we don't have to convert to the decimal. So it's a 4.9%. Oh, 4.9. Okay, period. We had 40 years, make 12 months because they said the compounded monthly. So it's a 480, right? And then here is a monthly, right? Can you see that? Annually, semi-annually, quarterly, monthly. So we click the monthly, right? So now we click feature value. I click the right side, feature value, which is FV, right? Then we get the negative. So from the smoker point of view, right? So he did not have money yet, so it's negative right now. But later on, he can get money, $457, 187. Did I dollars? $457,187, 35 cents. Yeah. Let me screenshot this one. Okay. Oh, there we go, right? So, oh, I need to, the page. Sorry, I need to delete everything. Otherwise, I cannot make a copy and paste. Copy. Here, paste. Oh, see. How about okay. And then screenshot, right? Screenshot. And then okay. So let me write for you. Can you see? We can see that this is a payment, right? So payment. And compounded monthly. We have a monthly, right? Compounded monthly. We can see that. So let me highlight compounded monthly. Okay, period. We have 40 years times 12 months, yeah? So we get 480 period. Okay, and then this is the question, right? We want to know about future value. So we click this one. Click for the answer. You guys okay with this? All right. Okay, then second question said that how much interest did the ex-smoker earn, right? Okay, so second part, so interest. So future value, oh, excuse me, future value minus investment times period, right? So there will be future value, which is 187.30 minus investment, which is 307.50. Period is 480, right? Okay, if we calculate, we get 309,058.7 and 35 cents. So can you check the answer? So this is the answer, right? Okay, you guys okay? All right, let's move on. Here is, they say that at the end of each month, let me highlight, at the end, okay, that's why we're using and here, right? Okay, those kind of things we said ordinary and annuity, yeah? Ordinary. So here is the future value. Let me hide this one first. The future value of ordinary annuity, right? So payment at end of each end of each of period, right? So we say that. Okay, this means oh, if we say that the monthly ordinary annuity, say making payment end of each period, right? So example, monthly, then we can say that at at end of January and the monthly payment at end of February and so on. Okay, we have a future value on annuity due. That's terminology, right? So we have one is ordinary annuity, and then we have the annuity due, right? Okay, this one, they say that, oh, this is at the end, and this is a beginning of its period. So here is, let me highlight. Okay, opposite of this one, right? Opposite of ordinary annuity. So monthly payment, the annuity due is, we can say that at beginning of January, right? And beginning of February, right? And we can keep doing that, right? Okay, so you guys understand what's the difference? Ordinary annuity and annuity due, right? Okay, this is the formula, but it's too much, right? So we are using not TVM calculator. So let's take a look at this one. Did I miss something? Okay. Sean wants to save $20,000 for the purchase of a new car 4 years from now. He can invest is an account that earn 4.8% interest compounded monthly, right? Okay. They say that there, okay, hold on a second. How much does he need to deposit at the beginning of each month, right? So beginning, so that is annuity due, right? Means annuity due. Okay, so we distinguish this one because we have a different formula, right? But we are going to use a TVM calculator. We can just click beginning, right? So beginning, right? So beginning here. The beginning, so beginning, yeah? All right. So look, this is a future value. So here is the future value, right? And then 4 years. So 4 years. And they said the compound monthly, right? Compound monthly. So we make 4 years times 12 months equal to, we have a 48 period. So there is 48, right? We can see that. Yeah. And then 4.8 interest, that would be R in that case. When it's in percent, so we can just using 4.8%. All right. Okay. Now, how much does he need to deposit at the beginning? So the payment, right? The payment is the question. So we do click here. And then they don't say about the present value. So no present value. So if we using TVM calculator, we get $377.27. Okay, second part. How much interest would he earn? So same as earlier, so future value minus, we have invest times the period, right? So there will be future value is 20,000 minus invest, which is payment. So 377.27.48. So if we calculate, we get $1,891.04. Okay? So once again, the payment is negative, right? So from Sean's point of view, he did not make a payment, investment, everything, so it's a negative value, okay? But then actually we are using positive. Make sense? Okay, now, so we just talk about the annuity due and ordinary annuity, right? Okay, so earlier we have invest like $50, $50, $50, and then at the end we get the big money, right? Now we have a big money present, then we will receive $5,000, $5,000 in, don't say how many years, maybe we can have 20 years after retire, right? Oh, they said here, next 20 years, yeah? So big money invest in present, right? And then this one, next 20 years, yeah? After retires, they can get money monthly, $5,000. So you guys okay with this? The earlier one, previous one. So we have a small amount invest month then future, present. Future value, we got big money, right? Now, we have big money, present, and then we get annuity for 20 years, right? Is it clear? Okay, so this formula, we seen this one earlier, right? Okay, so they say that ordinary annuity. So ordinary annuity, we make a payment, deposit, contribution, and we said that we had earlier, right? At the end of each time period, right? Okay, now we have annuity due, that is payment, deposit, contribution are made at beginning, right? Beginning of each time of period. All right. Okay, let's do. Oh, not the same one, right? Okay. So suppose Raul is retiring and wants to invest a single lump of money, right? So lump money, so it means the big money. Big money. How? No, that's not how. That's not. So that he can receive $5,000 at the end, right? The end of each year for the next 20 years. Suppose he can invest at 4% compounded yearly, right? We have yearly, compounded yearly. What single lump of money does he need to invest now in the present to receive payments of 5,000 at the end of every year for the next 20 years? Okay, so at the end, so we want to use TVM calculator and, right? So that is ordinary annuity, right? Okay, so let me go to the TVM calculator. Okay, so let's do it. Look, 5,000, that will be payment. He received payment, right? And next to 20 years, it will be period because compounded yearly, not the monthly, right? Monthly, then we have to times 12 months, right? Okay. Now, the question is the present value, right? So we click the present value. Okay, let's do it. TVN and same as n, right? So we keep the n and present value. That's the question. And payment, he will receive $5,000 for 20 years, right? So $5,000 and future value, we don't know. They don't say anything. Zero. Okay, the rate. Rate is 4%. 4%. Is it good? And then the period is 20 years, right? And the compound yearly, annually, same, right? Okay. We want to find out the present value, so we click this one. Let me screenshot. Oh, that's not the one. Oh. Okay, so let me do that for you. So we click this one, right? This is the question. So we click. So payment $5,000, we understand, and then future value. So we also want to use everything investment by end of 20 years. And then annual rate is at 4%, period is 20 years. Yeah, so years. And then compound yearly. Annually, same thing, right? Okay. Second part. How much interest did Raul earn? Okay, so we have to think, right? So he earned $5,000 times 20 years, right? Then payment years. Then he earned $10,000. Yeah. Okay. Then interest, right? So how much he earned the interest? So we have $10,000, and then he put the money, the lump of money, big money, right? So big money is 67,951.63, right? So basically, uh, what is called this one? He make money, right? So invest. This is investment. Big money. Earn. So if we calculate this one, we get 32,048.37. Yeah. So we get the answer like this. Okay, now looks like the last one. So same thing. The student gets a big lump of money, big money now, present, and then pay off the loan, right? Okay, so example to help pay for school, undergraduate took out $40,000 in student loan at 4.45% interest. After graduation, the standard repayment plan is to repay the loan in 10 years with equal payments made at the end of each month. At the end. So that is, this means ordinary annuity. Yeah, we make just end here, right? So and at the end, so end, right? Okay, now this is the present value. Present value. And then how much is the monthly payment, right? So this is the question. So we click this one, right? Okay, then everything's good, right? Period. They said that monthly, right? So there is a monthly. So period is 10 years times 12 months equal to, we have how much? 120 period, right? So there is a period, right? And then since they said monthly, so compound is monthly, right? Okay, then the number is $413.59 every month for 10 years. Okay, now second part, total interest. So total interest, similar with the earlier one. So how much total the student paid every month, right? So the student paid 413.59, 120 months, right? So payment times month minus present value, right? So that is $40,000. Okay, if we calculate, we get $9,630.80. Oh, we have one more. Okay. So last question here. Number 2. A recent college graduate charged $9,100 on his credit card. So this is a present value. And after noticing that the credit card company charges 15% interest compounded monthly, right? It's monthly, then we times 12, not 100. He stops charging on that account. He wished to pay off his balance in 2 years. Yeah, so 2 years times 12 months, which is 24 periods. And then they say that using automatic payment sent at the end. That's ordinary annuity, right? Ordinary annuity. Okay, we are using end here, right? Same end. Okay, present value and payment. That's the question. So we need to click this one. And future value, we make 0. Annual rate, 15%. Period is 24 periods. And then they said that compounded monthly. So we click that, right? So we get this much payment, $441.23. Okay. Now, how much total interest? So how much the students pay, right? Monthly. So payment times month. So there is a 441.23 times 24 and present value, right? Present value. So there will be 9,100. We calculate, we get 1,489.52. Okay, thank you for watching. Bye. Oh, can I stop?